Okay. All right. So this is the third example. I did one of a base to start off with that was really easy. I did one as an acid that was not. And here's one of a base that's not easy. Okay? All right. First things first, you got to write the equation down. I need to see this equation, including in the homework if you want to get full credit. Okay? I went by Austin's the other day. I remember it was just answers, 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 answers. Well, that's not going to get you any points, 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 points. All right? You're going to have to be able to show me the work. Otherwise, I don't know what you guys did. All right. Copy that question down, and let's do the equation. First of all, the equation. Okay. Aluminum hydroxide. Bases just dissolve in water. So it's AlOH3. Break it up. But this guy's a little different than the base we saw before, sodium hydroxide. And by the way, there's a little S. Remember back in the day, back in Chem 1 again, you used to ask me all the time. In the first half of the year, what does the S mean? What does the L mean? What does the AQ mean? And we kind of just ignored it while we were learning how to write formulas and how to do equations. We know now, because later on in the year, we got to solutions. And we talked about how that means solid, and then when it breaks up, it forms aluminum ions, aqueous, AQ, and hydroxide ions, aqueous. There's a big difference between aluminum aqueous and aluminum S. If I had written, if this was a chemical equation, and aluminum hydroxide were breaking up into something, and it formed aluminum metal, that would be ALS. It's a big difference. It's a chemical equation. It's a chemical change. This is just dissolving in water. Okay, so don't write that down. All right, let's do the next part again. This is all the work you'll need to show me when you're doing the regular problem. You already know, since it's 0.00241 molar of this, and it goes to completion, I have to balance this with a 3 there, right? Because I had 3 OHs here. I needed a 3 in front of that guy. And so therefore, I don't really care about aluminum. I'm just going to go right over to here, 3 times 0.00241 molar. So you basically know one guy off the bat, as soon as you're told the concentration. You know that hydroxide ion concentration is what? It's 3 times that, or what? 0.072? 0.0072 molar. Does that look good? Okay. All right. If I know the hydroxide, I want you to show me the equation. Kw equals hydronium times hydroxide. I know the hydroxide. I'm solving for hydronium. So hydronium is going to equal Kw over hydroxide, which is 1 times 10 to the negative 14th molar squared, over 0.0072 molar. Make sure you get your calculators out, do the math for that. You're going to have to do the use a calculator on a guy like this. There'll probably be on the test one that will be so easy you won't need to do it. It'll just be 1 times 10 to the. Glad Austin's copying all this down, getting this down good. You got all that already? Okay. What you got? You're amazing. You're ahead of the game in the thing, but you don't do any of it in the homework. It's not good. So what do you got for the answer for the hydronium? 1.39 negative 12. All right. So there's your hydronium. That's correct. Is that right? Everybody else get that? Okay. If that's your hydronium and that's your hydroxide, I know 2 of my 4 answers. Next thing I'm going to do is find my pH. The pH will be negative log of the hydronium, which is a negative log. And again, I'm going to need to use my log button on my calculator, 1.39 times 10 to the negative 12th. I don't remember how to do it. I remember back in the day, like I said, I think I told you yesterday, we used to use log charts. Anybody ever have to use a log chart for a math class? Besides Victor?
They're long.
What's that?
They're a long list.
Yeah, they are. Just like it's like looking at an index, and there's a whole bunch of numbers that basically fall between if the base 10, and you have to figure it out, looking it up there. But I don't even remember. Jesus, it's been so long. Nobody does that anymore because your calculators can all do it. And what do you get when you get your log of the negative log of that number? What do you get? 8.6 would be 11.9.
Yeah.
Is that right? Okay. So that's your pH. We all know what the pOH is. It's just going to be 14 minus that, or what? 2.1, is that right? Is that right? 14 minus 11.9? 2.1? All right, so that's a pH. All right, so look at it. Does it make sense that a base would have a pH of 11.9? Yeah, because we learned yesterday, I think y'all know, I'm sorry, we didn't learn yesterday. We learned in Chem 1 that I think you learned in biology. I think you learned in middle school that neutral on the scale is 7, right? Acidic is lower than 7, and basic is above 7. And now you know why. It's because it's the exponents. 10 to the negative 7th. All right, pH higher hydroniums actually have lower numbers because it's a negative exponent. Okay, that's why. All right. Okay, good enough for that. That's just a little. There will be some in the homework tonight, maybe 1 or 2 that are like this, but most of them tonight are going to be working backwards like this one. All right.
So this is really example 4.
This is I'm sorry. It should be example 4, not 3.
I don't know. I like her. Andy.
Okay. Copying that down. So I want you to find the molarity, and I give you the pH. All right. Well, this isn't very difficult, and I got it all worked out for you, so I don't have to write anything. You basically just have to rearrange the equation. What makes this a little weird is that you're going to have to take. Well, just watch. Normally, if I want to rearrange an equation and work backwards from an equation that's like just got x in it or something like that, it's pretty easy. But this time the x is actually got the log in it too, so I have to worry about how we do that. So let's just write it down from scratch. Here's my basic equation. pH equals the negative log of the hydronium. So there is a little hairy part to this. Instead of just solving it as is, I'm given the pH and I want hydronium. So that's the weird part about it, right? Okay, so I'm going to rearrange that. First thing I'll do, I'll take a negative of both sides, right? Because I want to get hydronium by himself with a positive value. So everybody agree I'm just going to multiply both sides by a -1. Okay. Now, what I have to do here, and your calculators can do it too, either second or inverse log, or it may even say 10 to the whatever power next to it. Okay? Depending on your calculator. All right, they're all different. Mine says, that old one I still use from forever ago is inverse. It says inverse log. Some of you will say second. Some of them will have a little button above it that says it. So you have to take the inverse log of both sides. The inverse log of the negative pH and the inverse log, of course, the inverse log of the hydronium is just a hydronium, right? Yeah.
You could just do 10 to the negative
10 to the negative pH.
Right. Well, I said your button will even say that. I know that. Yeah, your button will even say that on it. But it has to be negative pH. Some of the buttons will say that. Some of the buttons will say negative. So not all like a calculator like this probably doesn't have that. It probably just has log, and you have to take the inverse log of it. That's why I said either way.
That's 10 raised to the x power. Is that something?
That yours has, yours may have that button. I don't. But here, let me just show you. If you don't believe me, here's my black calculator, and it just says, it just has a log button. Okay, and then if you look above it, that's the 10 to the whatever power. Okay, but I just hit inverse log for that. All right, so if you do that, let's do the numbers in here. Ready? I know I'm looking for the inverse log of negative pH. It's basically the inverse log of negative 4.17. So what do I get?
6.8 times 10 to the negative 5.
Did everybody double check that you could use your calculator correctly on that? And you get, you get, what'd you say it was?
6.8 times 10 to the negative
6.8?
Yeah.
Exactly, because there's 3 significant figures.
Yeah, just 6.8.
Oh, I got 6.76.
All right, so 6.76. 6.76 times what? 5?
Yeah.
Okay, 5. I thought I heard somebody say 6. That was just fifth then?
That's it.
All right, so 6.76 times 10 to the negative fifth would be your concentration, working backwards. And there will be several you'll have to do tonight like that. And that's it. Now, I'll give you those problems right now. You work on those the rest of the period. And again, this is the easy stuff. Guess what we're going to start tomorrow? We're going to do the equilibrium ones. Okay.
Woo!